Hello, it's Mr. Knight. This is 2.6 for geometry, and we're looking more at proofs and so forth. So there's a few vocabulary words you need to go through. So proof is just a logical argument that shows a statement is true, right? So all these proofs we were doing, we're just going through a logical sequence to make a statement to show that a statement is true. And basically, it's in the question. They're asking you to prove something. Okay, that's the statement that we're trying to make. All right. So then you have a two-column proof, which is what you actually did in class today. So if I look at a two-column proof, you have the statement, okay, such as CD is equal to BA, and then you have a reason, and this is where you do your definition, your postulate, your theorem, are given. Okay, so that would be a two-column proof, and then a theorem is a statement that can be proven. All right, so theorem is a statement that can be proven. Then here's one theorem right here. It's the congruence of segments, and it says that segment congruence is reflexive, symmetric, and transitive. All right. If you remember what reflexive is, you might say that AB, and I'll use it in terms of segment, is equal to AB. All right. And then I might say for the symmetric, we might say something like AB is equal to BA. Okay. And then for the transitive, we might say something like if AB is equal to BC, and BC is equal to CD, then AB will be equal to CD. All right, so that would be your transitive, an example of transitive. And then we have another theorem here, congruence of angles, which would be the same thing. If you have reflexive, might be something like in the terms of angle A is equal to angle A, that would be reflexive. Symmetric might be angle ABC is equal to or congruent to angle CBA, all right, that would be symmetric. And then if you look at transitive, we're going to come right down here. We might say something like angle A is equal to or congruent to angle B, and angle B is congruent to angle C, therefore angle A is congruent to angle C. All right, so that would be an example of transitive. All right, so let's go on. Let's see what's next. All right, here's a proof. It's a two-column proof. Remember, you got the statement, you got the reason. So this is what they're given. It looks like a trapezoid. They're telling you that AD is 8. So I know that AD is 8. I also know that BC is 8. BC is 8. I also know that BC is equal to CD. So BC is equal to CD. We know that those are equal. And I want you to prove that AD is congruent to CD. AD is congruent to CD. So I'm proving that, let's use a different color here. I'm proving that AD is equal to CD. All right. So first thing you do is you write what's given. All right, that part was easy. And we can say that AD is equal to BC. That's your transitive property. And if you're not sure how that works, we know that AD is 8. We know that BC is 8. Therefore, we know that AD is equal to BC. Okay. So it's kind of like if I wanted to break that down further, AD is equal to 8. I know that 8 is equal to BC. Therefore, AD is equal to BC. That's how they use the transitive. All right. So now, step 3. I know that AD line A or segment AD is congruent to segment BC. Definition of congruent segments. And if we go back one slide, definition of congruent segments: a segment congruence is reflexive, symmetric, and transitive. All right. So we're saying that segment AD is congruent to BC. All right. And that's because of that statement right there. All right. Then if we look at number 4, we know that BC is congruent to CD because that's what was given right there. And then if you look, those are identical, right? So then I can come back and say that this is congruent to that. So basically, line segment AD is congruent to line segment CD. That's your transitive property, and that's exactly what we needed to prove. Okay, so that's your proof. All right. So let's go on. So here's the proof. I want you to stop the video. I want you to try to work through this, and then start the video back up, and then we'll check our answers. Okay? Okay. So I went ahead and worked out the proof, but let's go ahead and start. We'll go through it. We know that they're telling you that AD is equal to 12. We know that AB is equal to 12. We know that segment BC is congruent to segment CD, and segment AD is congruent to CD. And we need to prove this, that segment BC is congruent to BA. So generally, first we do our given. AD is equal to 12. AB is equal to 12. That's given. All right, then we know that AD is congruent, segment AD is congruent to segment AB. That's the definition of congruent segments. And if you, and what you're looking at is this right here. And then our next step right here, segment BC is congruent to segment CD, and segment AD is congruent to CD. That's given. That was given right here. Okay. Then we can say that segment CD, we're on that line right there, segment CD is congruent to segment BA, and we know that to be the transitive property. The reason being is that we're, if I go back up one right there, BC is equal to CD, and then AD is congruent to CD. Well, I know that AD and AB, let me use a different color. I know that AD and AB are congruent, therefore I know that BC is congruent to line segment, BC is congruent to line segment. I'm one off, sorry there guys. Let me erase that. Yeah, let me go back. All right, so I know that because of the transitive property that segment CD is congruent to segment BA. And then I also know that since CD is congruent to BA, I know that CD is congruent to BC, which is right there. And therefore, I can use the transitive property of congruence or segment congruence to state what I was actually trying to prove. All right, so let's go on. Let's see if I can do a better job on that proofs there. All right, so now we're going to name the property illustrated by this statement. So if I look at A, this would be the reflexive. If xy is equal to wz and wz is equal to pq, then xy is equal to pq. I'm sorry, that's transitive, my fault. And then if I look at if angle M, then so I know that A is a transitive. If angle M is congruent to angle N, then angle N is congruent to angle M, and that would be the symmetric. They're just reversed. So that would actually be the answer to to letter B right there. All right, so let's go on. Name the property illustrated by the statement. Angle R is equal to congruent to angle R. That would be your reflexive. And then 3 over here, if segment XY is congruent to segment PQ, then PQ is congruent to segment PQ is congruent to segment XY. That would be your symmetric. Number 4, segment XY is congruent to segment XY. That's reflexive. And then on number 5 there, if angle X is congruent to angle Y, and angle Y is congruent to angle Z, then angle X is congruent to angle Z, and that would be my transitive property. All right, so let's go on. Here's another proof. Now we're just looking at prove the transitive property of angle congruence. This is what we're given. Angle A is congruent to angle B, and angle B is congruent to angle C. So they want you to prove that angle A is congruent to angle C. So this is actually proving one of your properties. So first thing you start with is your given, right? That's easy. Then if we look at step 2, angle A is equal to angle B. That's your definition of congruent angles, because we know from, now this is the measure of angle A is equal to the measure of angle B, whether we're up here, you're actually identifying angles and using the term congruence. Here we're actually looking at a measurement, actual value, all right? And then if I look at step 3, measure of angle B is equal to the measure of angle C. Again, definition of congruence, which is right here. Okay. Then if I look at step 4, you have the measure of angle A is equal to the measure of angle C, and this would be your transitive property. Okay. So this is where if A equals B and B equals C, therefore A is equal to C. That's my transitive. Okay. And then if I look at my very last step, because I said that the measure of the angles are equal, therefore I know that the angles themselves are congruent, and that would be the definition of congruent angles. Okay. So we're going to stop right here. I want you to pause the video. I want you to work through this. You have to prove the transitive property of segment congruence, which is very similar to the angle congruence. And then once you're finished, just start the video back up. Okay, so let's review what you have. So let's look at the first step. Segment AB is congruent to segment BC. Segment BC is congruent to segment DC, or I'm sorry, CD, and that piece is given. If we look at the second piece there, AB is equal to BC. That's actual measurement. That's a definition of congruent segments. And that goes right back to right up here. And then the next step, BC is equal to CD. We're looking at actual values, and that's because, again, definition of congruent segments. And then we're looking at my next step, AB is equal to CD. And that would be your transitive, because if AB is equal to BC, BC is equal to CD, therefore AB is equal to CD. That's our transitive property of equality. And then our very last step, because the measure of AB is equal to the measure of CD, I know that the segment AB is congruent to segment DC, and that would be the definition of congruent segments. Okay? So, and I'm trying to hurry because this video is taking a long time. All right, so that is the end. All right, cool. So, your secret word is pizza. And I'll ask you that secret word tomorrow. So this concludes 2.6. Have an awesome day. We'll see you tomorrow.